Hi there. Uh, my name is Dave Elton. I'm the Soils Magician, and I'm going to show you a fabulous demonstration here in the Geotechnical Laboratory of effective stress. But instead of using effective stress in soils like we usually do here in the Geotech Lab, we're going to use potato chips, edible soil, as it were. We're going to do a little demonstration that shows you how effective stress works using these marvelous little potato chip bags here. There we go. Okay, now, effective stress is a measure of how hard those little potato chips are pushing on each other in the bag. If they push on each other really hard, high effective stress, they crush each other, and instead of having potato chips, we have potato dust, which isn't nearly as much fun to eat. So, instead, we're going to keep the effective stress very low, so the chips do not push on each other very hard, and they remain beautiful, wonderful chips worth eating. That's what we're going to do. And so we'll do the demonstration. Jane, later with the chip, later. We'll get the snacks later. Okay, now, the way we're going to do this, to demonstrate effective stress, is we're going to put this evil iron weight on top of those innocent little potato chips in there, and we'll see what happens. So here's the first weight. We put it on there. This, get on there. Okay, there's the first weight. And as you might imagine, nothing happened. At least that's what I imagine. Okay, and sure enough, what we did is we increased the total stress in there when we put the iron weight on, but we also increased the air pressure in there, pore air pressure as it were. So the difference between the two becomes the same number, a very small number, very low effective stress that's in there. Isn't that amazing? And so, as a result, we don't have any crushed potato chips. Later. Jane will eat the chips later. Okay, we have a very low effective stress, and the potato chips remain intact. As a matter of fact, we're going to put the second iron weight on there, and we should get the same effect. This works, right? Now then, here we go. Okay, we put the second weight on there, and as you might imagine, nothing has happened, which is exactly what we expected. That is to say, the total stress went up, but the air pressure went up the same amount, so the difference between the two remains the same. The chips are not pushing on each other very hard. I think we better hurry up with the experiment here. Now, what we're going to do to demonstrate effective stress change is we're going to change the pore water pressure in there by puncturing the bag with this evil knife. Yes! Usually they don't let professors have sharp objects in the lab, so this is really kind of a thrill. Okay, so we're going to poke a hole in the bag here, but first we're going to cast the evil spell on top of these potato chips. And it works like this. You say, such innocent little chips, so fresh and so lush. We stab you with the knife, and then you get crushed. Ha 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 ha! Okay. All right, so here it is. So we relieve the air pressure. We'll see what happens to the effective stress in the bag. There you have it. Crushed potato chips. The effective stress went way high because the pore pressure went way down. The difference between the two, total stress and pore water pressure is big. Effective stress is big. Potato dust results. There you have it.